Alrighty. Okay, class. Let's do some review. Let's start with Unit 1, Number Sense. Integer operations. Adding, subtracting, multiplying, and dividing integers. So let's start with number 1. We have -5 plus 4, a negative number. We're adding a positive number. We're making it more positive. So if you want to off to the side, pause it and do a number line to check these, you can do so. But I'm just going to run through these right here. So that is -1. -2 plus -5, that is -7. -4 minus 3, becoming more negative, -7. -8 minus bracket -12. Here's a little trick I like to do when you see two negative signs. Whoop, look at that, make it a giant positive sign. -8 plus 12 is 4. -4 times -11, a negative times a negative is a positive number, so that's 44. -9 times 6 is -54. That is a negative times a positive number is a negative number. 6 times 5, positive times a positive number is still a positive number. A positive times a negative number, 17 times -2 is -34. Division, -16 divided by -4. A negative divided by negative is a positive number, 4. 9 divided by -3 is -3. -4 divided by, -48 divided by 4 is -12. And 12 divided by 6 is 2. So there's a quick review on integer operations. Mixed and improper fractions. Convert 3 1/5 to an improper fraction. I like to think of this little trick is an upside down 7. So what that means is 3 times 5. 3 times 5 plus 1. And that is your numerator. So that's 3 times 5 is 15 plus 1 is 16. And the denominator is the same. So 16/5. And let's run through these. Convert 2 3/4 to an improper fraction. That's 2 times 4 is 8 and 3 is 11/4. Convert 11/3 to a mixed fraction. So how many times does 3 go into 11 without going over? That's 3 times. And the remainder is 2/3. 3 2/3. If you want to check that, 3 times 3 is 9 plus 2 is 11/3. So it does check. Convert 15/7 to a mixed fraction. 7 goes in 15 2 times without going over, remainder of 1, and the denominator stays the same, 2 1/7. Okay. Order of operations. Brackets, exponents, division, multiplication, addition, subtraction. Those are your rules. So we'll cover all of those elements of BEDMAS in one problem. So we have this monster of a problem. So you need to be able to know how to do something like this. So brackets is first. Do everything in the brackets first at the same time. So 32 minus 30 is 2 cubed minus 2 plus 1/2. And we have another set of brackets. 18 divided by 3 is 6 times 5 is 30. There we go. And the denominator, square root of 49 is 7. And 2 squared is 4. So 7 minus 4 is 3. Okay. That's what we have so far. Brackets, exponents. Do we have exponents? Yes, we do. 2 to the third. So that's 8 minus 2 plus 1/2 times 30 over 3. As you can see, I like to do one step at a time so you keep everything in line so we don't miss anything. Brackets, exponents. No more exponents. Do we have division and multiplication? Yes, we do. We have this 1/2 times 30. So let's rewrite everything. 8 minus 2 plus 1/2 times 30 is 15 over 3. And we're left with some addition and subtraction in the numerator. Let's fix that first. 8 minus 2 is 6 plus 15 is 21. And we're left with 21/3, and that is just equal to 7. There you go. BEDMAS problem. On to the next page. Number 4, prime factors, greatest common factors and lowest common multiple. For the numbers 120 and 450, determine the prime factors first. So let's try that. 120, and I'm going to use factor trees. Divide by 2, that's 60, divide by 2, that's 30, divide by 2, that's 15, divide by 3, and that's 5. So the prime factors of 120 are 2, 2, 2, 3, and 5. 450, what are the prime factors of 450? So let's divide by 3, that's 150. Divide by 3 again, that's 50. Divide by, let's try 2, that's 25. Divide by 5, and that is 5. So the prime factors of 450 is 3, 3, 2, 5, and 5. So on to the next part. So that's the prime factors. Let's look at greatest common factors. So GCF for short. Let's list out the prime factors for each number going across. So 120 equals 2 times 2 times 2 times 3 times 5. And 450, the prime factors are 2 times 3 times 3 times 5 times 5. Okay, so to find the greatest common factor of 120 and 450, what we need to do is look at what prime factors of each number are in common. So we have a 2 and a 2. And let's go down the road here. We have another 2 at 120, but no more 2's on 450, so we're done with the 2's. Let's go to the 3's. Do we have any 3's in common? Yes, we do. Both numbers have 3's. And let's try the 5. So do we have any 5's in common? Yes, we do, right there. And let's just scan one more time. Are there any more 3's for 120? Because I see another 3 for 450. No more 3's. And another 5 for 450. No more 5's up top. So we are done. So what are the greatest common factors? The greatest common factor of 120 and 450 are the prime factors that are uncommon multiplied together. 2 times 3 times 5. And 2 times 3 is 6 times 5 is 30. There is your greatest common factor. Okay, LCM, least common multiple. Once again, let's list out all the factors, the prime factors of each number. 120 is 2, but this time let us put it in exponential notation. So 120 is 2 cubed times 3 times 5, and there's a reason why we're doing this. We'll see here. 450. In terms of exponents, it's 2 times 3 squared times 5 squared. So to find the lowest or the least common multiple, what we need to do is look at each prime factor. So we have 2, 3, and 5. And find, for each prime factor, select the highest exponent of that prime factor and multiply them all together. So what does that look like? So let's start with a prime factor 2. What's the highest exponent that we see for the prime factor of 2 in either number? And that's 2 to the third. So that's 2 to the third. Prime factor of 3. What's the highest exponent? And that's 3 squared. And 5. What's the highest exponent? And that's a 2. So that is 8 times 9 times 25. I'm going to use a calculator to do that one. So that is 8 times 9 times 25, and that is 1,800. So that is your least common multiple. Okay? All right. One more example. For the numbers 54, 96, and 150, determine the prime factors, GCF, and LCM. So let's start with the prime factors. 54, factor tree time again. So divide by 2, that's 27. Divide by 3, that is 9. Divide by 3 again, and that is 3. So your prime factors are 2, 3, 3, and 3. 96, what are the prime factors? 2, 48. 2, 24, 2, 12, 2, 6, 2, and 3. So 2 times 2 times 2 times 2 times 2 times 3. There are your prime factors for 96. What about 150? Divide by 2, that's 75. Divide by 3, that's 25. Divide by 5, that is 5. For 2, so for 150, it's 2, 3, 5, and 5. Alright, GCF time. Again, let's line up each number. 54 equals 2 times 3 times 3 times 3. 96 is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 times 3. So 5 2's and 1 3. 150. We have a 2 times 3 times 5 times 5. So what does the GCF, so each of the numbers, what prime factors are in common? So we see 2's, we see a 3 here, a 3 here, and a 3 here. Okay, so I'm just going to draw a line to connect those. So the 3's are common. Do we have any more 3's common to the other numbers? Nope. Do we have any more 2's common to the other numbers? Nope. Do we have any 5's common to any of the numbers? No. So our greatest common factor of 54, 96, and 150 are the prime factors that are in common, which are just 2 and 3. So 2 times 3. So the greatest common factor is 6. Alrighty, last one. Least common multiple. This time let's write each of these in terms of their exponents. So 54 is 2 times 3 cubed. Yep. 96 is 2 to the 5th times 3, and 150. What do we got here? 2 times 3 times 5 squared. So for the least common multiple, again, we're selecting, the highest power of each prime number. So of the 2's, what's the highest power? It's 2 to the 5th. Okay? So we're selecting the highest power, the highest exponent of each prime number, so that's 2 to the 5th, and we'll multiply them together. So that's the 2's. What's the highest exponent of the prime number 3, prime factor of 3? And it's 3 to the 3rd. And finally, what's the highest exponent of the prime factor of 5? And that's 5 squared. So the LCM is 32 times 27 times 25, and let me do that on my calculator. 32 times 27 times 25, it's 21,600. 21,600. Okay, and that is your least common multiple. Alright, moving on. Adding, subtracting, multiplying, and dividing mixed fractions. The way I'll go about this is just converting a mixed fraction into an improper fraction for this one right here. So that's 2 times 5 is 10, and 2 is 12 fifths, minus 5 fourths. And now that we have it converted to a improper fraction, we need to find a common denominator so we can do the subtraction. So the common denominator I'll select is 20. So 5 goes in 24 times, so we need to multiply the numerator by 4, so that's 48 twentieths, minus, so the second one, 4 goes into 25 times, so that's 25. So we have 48 twentieths minus 25 twentieths, and that is 23 twentieths. And there's your answer. Okay? Alright, next one. 3 1/3 plus 4 3/5. Let's convert those to improper fractions. That is 10 thirds plus 4 times 5 is 20, 23 fifths. We need a common denominator again. We can't just add across. We need a common denominator first. So 15 is what works. So 15. So let's set that up. For 10 thirds, 3 goes into 15 5 times. So we say 10 times 5 is 50. And 5 goes into 15 3 times. So 3 times 23 is 69. And when we add up 50 plus 69, that is 119. 119 15ths. Okay? Multiplying fractions. So here we need to convert to an improper fraction first. We cannot just multiply across. So 4 times 5 is 20, 24 fifths times 1 times 7 is 7, and 3 is 10 sevenths. Now you could multiply across, but make life easy for yourself, folks, and let's reduce where we can. So that's 1 and 2. So we can see that those reduce nicely. So we have a much easier multiplication to do. 24 times 2 is 48. 1 times 7 is 7, and there you go, 48 sevenths. Okay? Dividing. So this requires an extra step. First step, as always, is convert the mixed fraction to an improper fraction. 3 times 3 is 9, and 2 is 11. That's 11 thirds divided by 2 times 6 is 12, and 1 is 13 sixths. Here, we cannot just divide across. We have to do that rule. In our notes, we have that funny saying, leave me, change me, flip me over. Leave me is the 11 thirds, so the first part, leave that alone. Change me is the division sign changes to multiplication sign. And flip me over is do exactly that. The 13 sixths flips over to a 6 13ths. Now you have something that you can multiply across. Again, make life easy for yourself. Reduce where you can. That 3 reduces to a 1. 6 reduces to a 2. Now my multiplication becomes much easier. Go across. 11 times 2 is 22. 1 times 13 is 13. So it's 22 thirteenths. Okay? There's your review on adding, subtracting, multiplying, and dividing mixed fractions. Let's go down. What else we got? Roots, radicals, and estimating values. Okay. Estimate. Square root of 10. So this requires knowledge of your perfect squares. What are the perfect squares? What are the square roots of the perfect squares that are closest to 10? So the ones I can think of right away is square root of 9 and square root of 16. So if you set up one of these inequalities here, we know that square root of 10 is greater than square root of 9, and square root of 16 is greater than square root of 10. So that's how you set it up. Find your perfect squares that are closest to 10. So we know that square root of 9 is 3, is less than square root of 10, is less than 4. So now this is much easier to estimate. We know that square root of 10 is somewhere between 3 and 4. If you're asking for just a whole number estimate, that square root of 10 is closer to the square root of 9, so we can say a basic estimate is that the square root of 10 is roughly equal to 3. Okay, if we're just asking for a whole number estimate. Okay, let's try something different. Square root of 220. So this will require your knowledge of the perfect squares beyond the number 10. So 220. So what I know is, I think it's 14. Let's try this. 14 times 14 is 196. So square root of 196 is less than square root of 220 is less than square root of 225. So those are the perfect squares that I know. Square root of 196 is 14 is less than the square root of 220 is less than, what's the square root of 225? It's a perfect square. That's 15. Now this is easier to estimate. The square root of 220 is somewhere between 14 and 15. And we see that 220 is closer to 225, so we can say, if we need a whole number estimate that 220, the square root of 220 is roughly equal to 15. Okay? Alright, converting entire radicals to a mixed radical. So square root of 48 is in the entire radical form. So what we need to do is look at the factors of 48 that equal a perfect square. If you know it right away, just do something like this. So we can say 16 times 3, because we know 16 times 3 is 48, and that 16 if we know remember the properties of radicals, is that you can split it up like this when we're multiplying radicals. So square root of 16 is 4, and the square root of 3 is just square root of 3. So this is the mixed radical form for square root of 3. If you didn't know that 16 was a perfect square in 48, you can do a factor tree. So 48 divided by 2 is 24, and then just keep doing it, right? So 12, 6, 2, and 3. Well, there you go. Look at that. 4 2's, and we know that equals 16, and that's where we use the perfect square of 16 to turn it into a mixed radical. Okay, so you can do this factor tree over here if you're not sure of the perfect square that's inside a number. Okay, let's do the next one. Convert 4 square root of 5 to an entire radical. This time, how do we do this? So take the coefficient, which is right here, the 4, square it, and throw it under the square root sign. So we know 4 squared is 16. So exactly as I said, 4 squared times 5. And then let's simplify that. That's 16 times 5, and that equals square root of 80. Okay? Place the following numbers in order from smallest to largest. Do not use a calculator. You can do this without a calculator. From what we just learned in, what we just learned in letter E, we're converting mixed radicals into an entire radical, and then the comparison becomes easier because here we have all these different values underneath the square root sign. So 2 square root of 5, again, we square the coefficient and put it under the radical, put it under the square root sign. So 2 squared is 4 times 5 is 20. So that's square root of 20. This one is 16 times 3 is 48, so that's square root of 48. 9 times 4 is 36, so that's the square root of 36. And 25 times 2 is 50, so that's square root of 50. Now the comparison becomes much easier. So we said from smallest to largest. So the smallest one obviously is the square root of 20. So that is the same as 2 square root of 5. The next largest is square root of 36, and we know that's the mixed radical of 3 square root of 4. And the next one is square root of 48, which is corresponding to 4 square root of 3. And the last one is square root of 50, which is 5 square root of 2. So to do these types of problems, you'll have to remember how to turn mixed radicals into entire radicals, and the comparison becomes much easier. Okay, moving on. Important rules on radicals. When you multiply them, you can multiply them together. So square root of 16 times square root of 4 equals square root of 64. You can also check it by saying 4 times 2, does that equal 8? Yes. So this is 4, this is 2, and this is 8, and it works out. Division of radicals, same deal. Square root of 36 divided by square root of 4, you can divide what's under the square root sign and put it under the square root sign. So this is true, but let's take a look here. That's 6 divided by 2 equals 3. That's 6 divided by 2 equals 3. So that checks, okay? Here, 5 minus 4, folks, does not equal 3, so don't do this. There is a subtraction sign. You cannot subtract what's under the square root sign. Does not work, okay? So don't do that. No. Same thing here. You can't add what's underneath the square root sign. So that's 5 plus 3 definitely does not equal square root of 34. Okay, so this is a big no as well. Don't do that. Okay. Substitution. Almost there to the finish line. Substitution. 2b squared minus 5b plus 6. Substitute in b equals negative 3. So use your brackets. 2 times negative 3 squared minus 5 times negative 3 plus 6. So 2, negative 3 squared is 9 minus 5 times negative 3 plus 6. 2 times 9 is 18. Negative 5 times negative 3 is 15 plus 6. 18 and 15 is 33 plus 6, and that is 39. Alright, I know we all love this one. Which of the following expressions is positive? So this is your number sense test on applying exponents and minding your brackets and negatives. Alright, let's do this. 3 squared. That is just 9. Negative 3 squared. Remember, what's that exponent attached to? It's attached to the number 3. It is not attached to that negative sign, or the negative 1. So that is negative 9. Okay? Sorry, let me just do this so we're not confused here. So that's 9. This is negative 9. Alright, this time, the exponent 2 is attached to the entire negative 3. So this time, it's like saying negative 3 times negative 3. 2 negatives make a positive, and that is 9. Negative, oh wow, this is, okay, negative times the bracket negative 3 squared. Okay, so that's negative 3 times negative 3. So that's negative 9, and that's just negative 9. Okay? 2 to the third, that is 2 times 2 times 2 equals 8. Negative 2 to the third, that exponent of 3 is only attached to the 2, okay? So that is negative 8. Negative 2 in brackets raised to the third exponent, okay, raised to the 3. So that is negative 2 times negative 2 times negative 2, and that is negative 8. Alright, we have negative 2 times negative 2 times negative 2. Remember that exponent means repeated multiplication. So we know that negative 2 times negative 2 times negative 2 is negative 8. So we have a negative 8, and that is 8. Okay? Okay. Answer the question. Which of the following expressions is positive? So let's circle all the ones that are positive. Definitely positive. Definitely positive. Definitely positive. And definitely positive. Alright folks, that is it. That is a quick review on the entire Unit 1 of all the important concepts for Unit 1 number sense.